Start now. Welcome to everyone to today's MDI Science Cafe on PFAS or PFAS, which is a question we can try to get through at some point later. Regional differences in how you pronounce these substances. Also, arsenic, other concerning substances in our environment. I'm Fred Bever, the Chief Communications Officer at MDI Bio Lab. And we have three guests today with us who can help us understand risks posed by these substances in our water and elsewhere. Dr. Jane Disney is here. She operates the BioLab's Community Environmental Health Laboratory, which includes its growing Healthy Water, Healthy Aging program, which is providing testing for PFAS contaminants for prioritized households in Maine, and looking at other substances of concern as well. Also joining us is Dr. Ju-Young Shim. She's a visiting scientist here, or has been. She's a faculty member at the University of Maine at Augusta, and she's using C. elegans roundworms as a model for studying risks from these natural and man-made substances in our environment. First up, though, will be Dr. Ned Calonge, who's with us. He chaired a recent National Academies of Sciences report on PFAS health risks that includes important information for citizens, clinicians, and regulators, also basic scientists. He is Associate Dean for Public Health Practice at the Colorado School of Public Health. He is also Chief Medical Officer for the state of Colorado. And we'll get to ask him some questions in a bit. Please write your questions in the chat box, and we have staff monitoring that. If you prefer to just speak up, we'll try to get to that near the end of the hour. Please raise your hand by clicking on the reactions button that you'll see at the bottom of your screen. I'm going to note that this is our first online-only event in several months, so we may have a few glitches here and there. But let's keep going anyhow. Dr. Calonge is going to give us an overview of that report he led the authorship of and its findings. Welcome, Dr. Calonge. Thank you for joining us.
Thanks, Fred. I appreciate it. Can everyone hear me okay? Seems that way. And with everyone's permission, I know that I don't want to do death by PowerPoint, but I will do better with a few slides. And so I'm going to try to share my screen.
I'll note that the links to the report that he co-authored, as well as to Jane's program, is in the chat right now, and we'll put it up again later.
I appreciate being asked to do this. I have to tell you that MDI has a long lead time. I think I was asked to do this.
Where it says what? There's a red circle.
Well, that's
several months ago. And I'm excited to be here now and going ahead with the talk. Let's see here if I go here. So we did this study. The National Academies of Science, Engineering, and Medicine is a group that was actually started in 1864 by President Lincoln and modified over time. It was just the Academies of Science at the time. It was meant to be an independent body that the government could turn to do studies from a kind of a honest third-party broker on different issues. And so we were asked and funded by the government to do a study looking at PFAS exposure, testing, and clinical follow-up. So I want to give you a little bit of background about PFAS. I think it's important to point out that the interest in this work in PFAS really originated with who I would call citizen scientists. These are individuals in the community, mainly in the Midwest and the Northeast, who noticed what they felt were kind of risks for conditions that surprised them because of who they were happening to and the frequency. And so this kind of local citizen scientist interest in PFAS in drinking water got started. And it translated to getting the attention of policymakers in Washington. So Andrea Amico, who is the head of a group called Testing for Peace, had this quote that the communities with water contamination were exposed without their consent. Now they have to fight tooth and nail to get a blood test result just to know if they had an exposure. It seems wrong. We don't have the answers yet, but not testing for them is not the right answer. So this was at a workshop in 2018 that preceded sitting the committee to do this study. So PFAS stands for something. It's per and polyfluoral alkyl substances. There are now over 12,000 human-made substances, only a small fraction of which we've studied. They vary in chemical and physical properties, and this phrase is important. They bioaccumulate, and that means they build up in our bodies if we ingest them. And then they persist in the environment. And the issue around persisting in the environment is why they're sometimes called forever chemicals. And it has to do with this bond between carbon and fluoride that's just extremely hard to break. That fluoride bond is also interesting because it gives these compounds unique characteristics that make them attractive for consumer products. They've now become ubiquitous in human serum and in the environment. They are associated with a very diverse array of health effects. We have EPA lifetime health advisories for 4 PFAS, and they're looking for tightening those down even more. And the last thing I will tell you is that what I'm going to tell you today was a point-in-time study, and the science is rapidly evolving. And so what we published a little bit over a year ago has already changed in terms of how much more we know about it. So this is just a slide to give you an idea of how ubiquitous the use of PFAS is in the environment. So I'll point out just ones like you'll see dental floss. So anytime you see the word comfort in front of the 2 words dental floss, it means it's a PFAS containing dental floss, and it's because it glides easily between the teeth. You'll see cosmetics up there. You'll see rain gear, particularly waterproof rain gear that's not just nylon based. You'll see fast food containers, paint, nonstick pans, firefighting foam, and things like waterproofing on fabrics. And so because the compound is a good lubricant, doesn't burn, and creates a non-porous barrier for fluids and grease, these are some of the characteristics that makes it very attractive for consumer products. And so if you think about how you have been or will be exposed to PFAS in the environment, this slide tries to tackle a lot of these issues at once. So drinking water is by far not necessarily the largest contributor to everyone's body burden, but probably the most ubiquitous source. And how did it get into the drinking water? Well, it has to do, if you were a factory, you have effluent. And as the effluent flows out of the factory, it got into both surface water and into other water supplies and contaminated the drinking water. You can get it through your diet in a couple of ways. One is that you could use sludge as a fertilizer for your crops. And if you do that, then your crops will contain PFAS. If by going on up the food chain, cattle, for example, might eat PFAS-containing foods, it will bioaccumulate in cows and in cow's milk. And so we see it in diet. We know it can be aerosolized as dust or in the air. Talked about consumer products. And then we also know that it can be passed from mom to baby from the birthing parent to the baby during pregnancy, and then passed to the infant during breastfeeding. So there are a lot of routes of exposure, and that becomes interesting when we get to recommendations. At the time we finished the study, there were almost 3,000 sites in 50 states and 2 territories. If we redid this map today, you would see more. You see Maine up there where Maine always sits. And then you see some remarkable measures around the rest of the Northeast and around the coast. So we were asked to do this study, and we do it in something called a statement of task. And they really wanted us to talk about the health effects of PFAS, to talk about the exposure pathways we talked about, and to give advice to update how public health talks to clinicians about what to do about PFAS testing and follow-up. CDC is the Centers for Disease Control. ATSDR stands for the Agency for Toxic Substances and Disease Registry. ATSDR is a group that keeps track of chemicals in the environment and what they do in terms of human health. So while EPA regulates exposures in the environment, ATSDR hands them the worries about the levels of human health to regulate around. So they work together. I just want to say a couple things about the approach that we used. And the first one is very important both for the national academies, but I think for going forward and thinking about environmental exposures. We started with extensive community engagement, an extensive engagement with real people serving as concerned citizens and citizen scientists in the environment who had a story to tell or who had done their own reading and knew every bit as much about PFAS as many people on the committee did. And then the second thing I wanted to say is that this is an evidence-based report. So we had to move from what I would say anecdote and kind of community voice-based evidence to what we could show in the medical literature. And so those are 2 important part of the aspects of the recommendations that we came up with. We do classify things typically at the national academies and then other evidence-based issues on kind of the strength of association with the disease. These were the categories we used. Sufficient use of an association is somewhere where we say we don't think this is due to chance alone. Limited or suggestive is a moderate certainty level. So it's still possible that there's another issue like bias or chance, but we're still moderately confident about the association. I'm not going to talk about any of the inadequates. There are a lot of conditions that people have brought up, and you might bring up about having possible connections with PFAS, and yet the evidence isn't quite in yet, and it may be in the future. So there were 4 conditions that fell into our category of sufficient evidence of an association. And these included kind of problems with the immune system. And that translated into measuring whether or not children or adults had sufficient antibody responses after vaccination. And we showed it was decreased for people who had high PFAS levels. We don't know whether that translates to the vaccine not working. However, we do know that antibody response is part of the important aspects of immunizations. Then we found that it was associated with high cholesterol in both adults and children. We found very small decreases in fetal and infant growth. Not enough that babies would be born with low birth weights or not hit the growth curve, but they were significant in and consistent in being seen across different studies, even though they were small. And then the last one was an increased risk of kidney cancer. And we don't really know of any other risk factors for kidney cancer. And so to find one is remarkable and makes it more likely that this is actually due to the exposure. Then you see there's a high list of limited suggestive evidence. So breast cancer in adults, testicular cancer, some metabolism issues with liver inflammation, an increased risk of something we call pregnancy-induced hypertension, thyroid disease or dysfunction in adults, and risk of an autoimmune condition called ulcerative colitis. And so we were confident in putting out conclusions about associations with these conditions. So that led us to recommendations, and I'm getting towards the end of the slides if you are worrying. We talked about exposure reduction, both in the general public and those who actually had occupational exposures. And for the general public, we talked about filters for drinking water. We talked about understanding that your food could be contaminated and working with your local public health agency around food advisories or other concerns. And then we had this issue around breast milk because we know PFAS gets into breast milk, and therefore we know that infants are ingesting it if they're breastfed. We were not prepared to make any recommendations about being hesitant about breast milk. And the reason is that the benefits of breast milk feeding for infants are really well known. And all of the major medical organizations all strongly recommend breastfeeding your infant. That's on the positive side. On the negative side, we just don't know. So we have no measurement of any adverse health effects associated with having a higher PFAS level as an infant due to breastfeeding. So we ended up basically saying we needed more studies. And then I'll just spend a little time on what we decided to tell clinicians they should do for people with high levels. I only show this slide to bring up a couple of major points. One is that there is a serum level for which there is evidence of no adverse effects. This comes from work in Europe and in Germany and Europe more generally. And there's kind of a cutoff where it's just unlikely that anything that happens was due to PFAS. On the other hand, there's a very high level where there is an increased risk of adverse events, and we might want to give people different recommendations. And then there's this huge gap in between where we can't say there's no effect, and we say there probably is an effect as you get towards the higher end, especially for sensitive people such as pregnant women and children. So I just wanted to kind of give you an idea. This range that you see here that we would provide to clinicians is the first time a range has ever been suggested, and it will change as we do more research. But it was the best we could do when the report came out. So what does that range translate to for you and your clinician thinking about what you should do differently? If you're below the 2, just do what you always do. If you're at that next level, clinicians should talk about you should reduce sources of PFAS in your life because that could decrease your level over time. And then a few recommendations about these are things that we tell patients to do anyway. Get your cholesterol tested, make sure you look for high blood pressure in pregnancy, and get screened for breast cancer based on age and your risk factors. And you might say, well, don't we do these already? And the answer is, yes, but honestly, we're not very good, both as patients and then clinicians in the United States, following these evidence-based guidelines. So we know that less than half of people in the United States have an adequate testing of the cholesterol level, and probably only half of those, or a little bit more, are adequately treated. And yet we know screening for cholesterol and treating high cholesterol saves lives. So what we said was to clinicians, you know, you should be doing these things anyway, but if your patient has a level in this middle range, you should really make sure you prioritize it. And then for the high level patients, we said you should start screening for cholesterol at a lower age. You should do thyroid testing on your patients when they come in to see you for well visits. You should look for signs and symptoms of kidney cancer, including doing a blood test. A urine test for blood. And then for patients 15 and over, at least assess them for whether or not they might have testicular cancer or ulcerative colitis. So that was kind of the place where the committee came down in additional things to do. I think the last slide just tells you that we told ATSDR things are changing quickly. We think they should use community engagement and then scientific research and synthesis to inform them and update the recommendations every 2 years. So I want to get off of the slides and onto your screen. You saw in the chat the URL. I'm terrible at getting URLs out of the Zoom. And so I always have a shortcut for doing everything. If you type NAS PFAS into your browser, it'll pop up and you'll be able to find it. And with that, I'm gonna stop sharing for now. And Fred and others, hopefully turn things over for questions.
Thank you, Dr. Calonge. That was admirably lucid and compact, and there's a lot to unpack there as well. I'll just, and I'd like to encourage people to put questions in the chat before we start talking about the work that Jane is doing, particularly around community engagement, and what Ju-Young Shim is doing around actual physical cellular mechanics of all of this. But just a couple of questions, Dr. Calonge. First, it's about pathways. You spoke about the nanograms per milliliter in human serum. How do we relate that to? I mean, there's a suggested limit, I believe, that the EPA has adopted of 20 parts per million or trillion rather, in drinking water. How do we relate those two numbers in the pathways? Am I more at risk from wearing a slick raincoat or less at risk from drinking water? What's most like, or being a firefighter is something you mentioned in your report, is a high risk because PFAS is used in firefighting substances. Who is most at risk and who should ask their doctor for a blood serum test?
So I heard, I think, 2 questions in there, Fred, and I'll try to take them one at a time. One of the evidence gaps, which we've not filled in yet, is the relationship between drinking water levels and serum levels, and then how long you have to drink PFAS contaminated water at a certain level to translate to a serum level. So that is the evidence gap that we don't have. And it's hard to fill in because people move around, people have different habits, and you may move from an area of high PFAS contamination to a low one. And the good news is your level will go down over time. It goes down slowly is one of our concerns. But that's an evidence gap that we're still wrestling with. And I think the EPA, thinking about a new standard, is, well, maybe we should just say you shouldn't have any in your drinking water. And that has ramifications for how we invest in our drinking water systems across the country. It makes it tough on people with well water who are going to have to figure out how to put the appropriate filters in between where they get their water and where it comes out where they use it. It's a really great question. Now to the issue about who should be tested. So we were pretty direct in our recommendation. We think clinicians should discuss testing with any patient who lives in an area where we know there's drinking water contamination from PFAS. And your local health department has these answers. There is I think you already have a map. I believe you have a map of PFAS contamination across Maine. So a lot of that information is already known about who's in a high area, who's in a low area. So I live in the Metro Denver area, even though there's a lot of PFAS contamination near military bases in our state, there aren't many in Denver. So I don't have that high contamination. However, Colorado Springs has an Air Force base, and we know that Air Force practices fire suppression. They use PFAS-containing foam, or have, during those during those exercises. And so the groundwater and even deeper water sources around Colorado Springs have an increased level of PFAS in them. So now we're actually looking at serum levels of people who live in that area. So military bases are a common source of thinking about, might your water be contaminated? Factories are where we first saw them. So not to mention any companies, but companies who made things like stick-free cookware and water-resistant clothing. There are chances that those are areas that contamination could occur. And then there are occupations. So if you actually work at making PFAS, that puts you at increased risk. If you're a firefighter, it's not just the foam. We impregnate firefighting equipment and clothing with PFAS because of the remarkable ability to resist flame and not get drenched with water. And so there are occupations that we think are high as well.
Thanks very much, Ned. We certainly have lots of interesting questions coming in. I think I'll start by bringing a couple of them together. Alan Kleiman asked how PFAS compounds might affect the endocrine system. And V. Pennington, and I'm sorry, I don't know what the V stands for, asks whether, excuse me, I'll get to V. Pennington's. There was another question from Pat G about bioaccumulation, any particular kinds of tissues. So Alan Kleiman asks about endocrine system, and another question is about, do we know which particular tissues may be most commonly bioaccumulators?
Yeah, so great questions again. So clearly the thyroid axis is affected by PFAS. It's interesting. It's consistent in the studies that there's a relationship with thyroid dysfunction. The interesting part is it can be hyperthyroid or hypothyroid. And so there's a complex relationship that may have something to do with the patients themselves. And then it could be an individual PFAS compounds. Remember, it's a family of compounds. And so some may increase thyroid hormone levels and some may decrease, but that's clear. There are some other associations that might look at other hormone systems. We haven't found any definitive relationships around like osteoporosis and that particular endocrine section. there were some studies looking at what the committee ended up saying were minor impacts on the development of external genitalia in infants. But they were things like how wide the space was between the back of the vagina and the front of the anus. And none of them were clinically significant. But that to me says, is there another, like in the sex hormones, might there be other impacts? So those are things that we might know more about as we go forward, but definitely thyroid is impacted. The second question is great because we've not studied other matrices. We talked about it a lot in the committee because one might think that fat tissue might be a normal place to store it, or liver tissue where you might see buildup of PFAS that would then interact with the blood as things move forward. This time, the only thing we really know about is serum and blood. And I understand that's not a satisfying answer. I will tell you that the eight PFASs stopped being made in the 80s and 90s because of the kind of emerging evidence of connection with human health. And there's a survey called NHANES that's done every year. And they've started, as part of that survey, taking serum samples and looking at PFAS levels. And the good news from my standpoint is, since they stopped making them, those levels have gone down consistently over the years. So if they're building up in other body tissues, they are then coming back into the blood, and those levels are going down over time. No, we haven't done any sampling of like kidney tissue to see if PFAS accumulates there. That would be a little unusual because things tend not to accumulate in the kidneys, but it's just an area of additional research.
And so you mentioned at the outset that there's a family of 12,000 compounds, I think. And Rachel Criswell asks about the 6 sentinels, or the sum of 6 that was chosen for developing the report, which she says she's been using in local tests for PFAS, PFBS, PFHXS, PFAS, et cetera. And she's wondering if what you think of that group as a reliable proxy for the panoply of risk out there, if you will.
Yeah, so this was another challenge. We looked at 7 total, and they were the ones that are included in serum testing by NHANES, and we were told to look at ATSDR and CDC. These are longer chain PFAS. They have varying half-lives. Some of them are half-life is how long you persist in the body or how long you persist in the environment. So some of them do break down, but one might take years for it to decrease by half in your body, and another might take days. And then different PFAS are implicated in different diseases. So we had a very complex problem, and we turned to, again, to Europe to look at how they had handled them. And what they ended up doing was adding the amounts together. And that's where those levels of 2 to 20, at 20 and above, and less than 2 came from, that simple addition of serum levels. If you were a good toxicologist, you would say that's a weakness of the report. If you're a public health person whose concern is to be as conservative and as protective of public health as possible, that's a reasonable approach, and that's the way we looked at it. What it leaves out is everything else. And so as as industry turned away from long chain PFAS, they turned to shorter chain PFASs. that have the same kind of repellent and lubricating characteristics. And all I can say is that we haven't studied those. We don't have sufficient information. And so the idea of, as tests are able to look at new PFAS, thinking about that total simple addition of the amount in a body is the way we are currently recommending ATSDR think about the issue. I just have to say that the audience is going to all of the areas where we don't know stuff, which just shows a level of interest and insight that is remarkable.
What about DA Reppert asks, what about, so let's say I go home and I throw out all my scratched up Teflon cooking equipment. Well, should I just throw it away? How does one dispose of suspected PFAS sources?
Yeah. Well, yeah,
Safely?
I would throw it away. So, and hoping that the current science around landfill protection is sufficient to keep it from leaching further into groundwater. We've gotten better at that over time. It would be best in a hazardous waste landfill. Those are hard to find and almost never free. But it is a thought that you could put it into. There are some companies who are working on strategies to break the carbon fluoride bond. And my understanding is that they're moving along. They think it's an answer to drinking water and other sources, but we're not there yet. In Colorado, the state health department where I work has put together a take-back program for PFAS containing firefighting foam. And when I saw that, I said, well, what are we doing with it? Because we have to store it until we can figure out a reliable way to dispose of it. So okay, another great problem we face.
You mentioned landfills, and at the outset, you also talked about the importance of citizen engagement in all of this. And I know that Jane Disney, with her Healthy Water, Healthy Aging program, which she sort of started out looking at arsenic, but now she's beginning to make a study of PFAS as well, and working on precisely that, putting tools in people's hands for understanding at least where exposure may be. Jane, can you talk a little bit about what your work has been around this?
Sure. First of all, I want to say thank you, Ned, for the work that you and your colleagues did on this report. It's just so essential for those of us working at the grassroots level that we have a place to turn when people ask for help. And so, you know, when people end up with high PFAS in their wells, then they need to hear, there need to be some recommendations about, like, should you bring this up to your physician? You know, what are your next steps? And so that's something we're trying to do. I'm going to be adapting some things from your report that we can use in our community conversations. But I want to share with you our website for what we are doing locally, and then show you some tools we're creating to try to facilitate community conversations about what to do next. So this, oh, I knew this would happen. I've been looking things up as we go, as some of you probably are, which got me off my website. Let me try to share my screen again. Here we go. So this website was originally created for a school-based program that I run. It's a Science Education Partnership Award program, and we engage kids and teachers across Maine and New Hampshire in collecting their well water for analysis of arsenic and other toxic metals. And one day I was giving a talk, as Ned has been giving talks and inspiring people. And somebody from the Center for Excellence in Aging and Health down at University of New England heard me and said, wow, it's great that these kids and teachers are out there in the community getting these water samples. I'd really like to see older Mainers have a chance to get some support for getting their wells tested. And so, the infrastructure was in place through our school-based program to actually engage with people. So we created this Healthy Water, Healthy Aging project, really to start looking at arsenic. We initiated a drinking water survey so we could understand more about people's drinking water sources, well types, any other information they had about how much water they drank per day, how long they've lived in their homes, and all of this. And then we asked people, what are your other drinking water concerns? And PFAS was coming up as something that people were really, really concerned about. And so, as much as the project is ongoing, arsenic is a big issue across the New England states, as well as PFAS. And I'm telling you, it's disconcerting to think that people might have both, high levels of these metals in combination with high levels of PFAS in their wells. And what's the interplay there? We don't know. But we are continuing to both collect the metals, and now we have been engaging people in collecting well water samples for PFAS. As most of you probably know, testing for PFAS is super expensive, and we were really fortunate that we got some initial funding from the Chan School of Public Health at Harvard and their Community Engagement Corps. Long story short, we've been prioritizing certain people around the state in terms of their proximity to septage and sludge applications. But more recently, we got a phone call from somebody living near MDI High School and told us that our local high school had PFAS. And we created this interactive map with residents around the high school to begin to try to understand, well, if the high school is affected and then we have a neighbor who has concerns and turns out that they had high levels of PFAS in their well, who else in proximity to the high school also has high PFAS? So we've tested really just a couple of areas of surface water flowing out of the high school area. This is MDI High School. They had 85 parts per trillion in their drinking water. A very close neighbor here with 24.4 and another neighbor with 64.06 part per trillion. And then as we moved away from the high school, some of the households had somewhat lower levels, but directly down this stream is where the original homeowner had a level of 19.5, just under the 20 part per trillion level that's deemed really the cutoff here in Maine for what's healthy, I guess. So this has brought us to thinking about schools as hubs of PFAS contamination. And when I started looking into it, I found that there's schools all over Maine that are rural, that are on private water, that have elevated PFAS chemicals. In Maine, it's the sum of 6 different chemicals have to be under 20, and we have Noblesboro Central School at 22.6, or Bristol Elementary School at 20.5, but Blue Hill Consolidated School, Lyman Elementary School, Washington Academy, Chebeague School out on Chebeague Island, like what's going on with schools? And so we are not sure. I think the schools are not sure. We wonder about the waxes that were used to buff the floors over time. But these schools that are on private water systems potentially have contaminated their surrounding soils, and the PFAS is percolated down into the groundwater and is moving out into the surrounding community. We've noticed a lot of schools are like in the teens or just about 20, and these schools are ones that aren't really being prioritized at all. That's another question from me, Ned, is like 20's bad and 11's okay. I mean, but anyhow, it's hard to know what to tell people, but just to give them as much information as you can. And some people are going to have to make their own decisions. But yeah, we went over and looked at Tremont School, had 19.9 parts per trillion, and the school wasn't doing anything about it. But now that we've brought this to everyone's attention, they're going to put a filtration system on. The high school has concerns about whether or not they've dealt with their PFAS problem. So they went and they looked at their effluent that was flowing out of the high school. And even though they put a filtration system on, they still are getting very high levels of PFAS still coming out of the school. So where's it coming from? If they're filtering their incoming water, then it's being reintroduced in the school as it goes back out into the watershed. So all these people will remain at risk of potential contamination of their wells as long as the school can't reduce what it's sending out, even though they filtered the water that's coming in. So this is the kind of work we're doing on the ground, and people are welcome to explore these maps and tools. We're using these for conversation pieces as we move forward and try to create a model for how you deal with this at this local level.
Dr. Calonge, thank you, Jane. If I'm correct, the federal government has proposed a new rule that would reduce that allowable, or the recommended limit, to non-detectable. Is that correct?
Yeah, or the lowest number detectable is what they, and so Jane, that has ramifications for every drinking water program in the U.S. And it's been controversial because of that lack of connectivity between like that level of 11 and what does that translate to? I will tell you, it translates to some level of serum PFAS. It has to, because that's a typical route of entry. Whether it gets above that 2 level, how high above 2 it goes, that's where the evidence is missing. And I think that was part of the reason EPA wants to reduce the level. They're basically trying to say we would like the level to be nothing. And given that we can't measure nothing, we're going to set it here. The flip side about to the ubiquitous nature is someone has already pointed out that rainwater has PFAS levels above that new standard. And so trying to balance the risk, which would be least at none, right, with what we need to expend in resources to get there, is what I think you're going to see play out really in the next month or so, because I think EPA has been talking about an October release, although I think I heard yesterday they might let it slip till January.
So with the clock running down a little bit, I do want to bring in Dr. Shim, who's been trying to look at some of the mechanisms, or at least begin to figure out how to look at the mechanisms that may be at work. I sort of have a basic question first for you, Dr. Shim, and Dr. Calonge, if you want to weigh in, which is just that, is it the unbreakable bond that makes it likely what can drive disease development or accelerate diseases? Or do we not know?
Fred, we don't have the answer to that.
Okay, thank you.
So we don't, these are associational studies. I feel confident enough in saying there's an association that could very well be causal, mainly because of the consistency and the strength of the association, and no like reasonable other reasons. So for me, kidney cancer drives that one. I can't think of any other reason, what we would call confounders or other explanations for why the individuals with a higher risk of kidney cancer would have that, other than this one exposure. But we don't have the mechanism down, and it's a great question. And Dr. Shin, I did put up your slides. I don't know if you want me to put those back down until you introduce yourself, or...
No, that's okay. This is good. Thank you. So, hello everyone. I'm Ju-Young Shim. I work at University of Maine in Augusta, but I also have worked very closely with Dr. Jane Disney through the CEPA program. She just introduced the school-based citizen science program on drinking water problems, concentrate on heavy metals, but also I'm a toxicologist, and I'm running a small research lab at UMA. And I was also doing a small part of the arsenic toxicity using animal models such as C. elegans. But also I'm showing you the planaria, which is another simple flatworm used for the studies using animal model in toxicology and also aging. So I just like to share the motivation to switch to here was mostly due to the COVID, that almost 2 years, the research in person was very hard. So my students wanted to continue the research, which planaria model was able, that students can do, actually setting up at home research to do some of the toxicological research. And switching, so the Ned has introduced those epidemiological and human studies and their summaries. But in the toxicologist or scientist level, we try to also answer what are the mechanisms, what is the mechanistic pathways underlying those outcomes in human health effect. So using, for example, planaria, we can do studies that showing any damage to the gene level DNA or tissue level, or in any type of developing cancer, or those that might be related to the human health. And also a lot of animal study use as developing new drugs or pharmaceutical interventions as well. So there are some studies using these animals in table 1 that are done for recent years on PFAS toxicology. Next slide, please. Can you move to the next slide? Okay, thank you. So basically, I like to just show you a glimpse of what our students produce in terms of the data. So we use planaria and we expose to animals in different concentration of PFAS, which is one of those, the 6 centennial PFAS group. And what they measure is following overview of the assay. One of the assay was to measure the behavior changes, or the motilities of the animals after exposed to those the different concentration of PFAS. So we found actually differences in different level of exposure. However, there are a lot of variabilities, and so we are trying to also repeat this experiment, as well as qualitatively. Also, I like to just show the representative of different planarias that were exposed to different concentrations. So there are changes in morphology in there as well. So what our lab is trying to do is, again, there are a lot of unanswered questions on PFAS toxicology, or from the epidemiological studies, and to using this animal in controlled scientific laboratories, we can hopefully reveal some of the underlying mechanisms that results in those the health effects, like Dr. Calonge just introduced us to. So I'll just leave it that. I think we want to have some time for questions.
Certainly, if people want to raise their hands or add to the to the chat, Dr. Shim, you did also start to take a look. I sort of pitched this as being about C. elegans, but of course you've done this work with planaria. However, you did start, and C. elegans is a platform or a model for human health that we're increasingly looking at MDI Biological Laboratory. You started to look at that a little bit this summer when you were visiting scientists at the lab. Is that right?
Right.
With C.
So,
elegans.
yeah, during the summer, basically, we were trying to develop a quick biosensor using C. elegans to gauge what's in the well water that causing maybe differences in different metrics that we were able to measure using C. elegans. So we actually use well water Jane Disney collected right around locally around MDI. And we expose C. elegans to those well waters, and we were able to measure different health metrics, to those exposure. And we were also following those changes from young to the older age worms. So we're bringing the toxicological study as well as a study in aging kind of population as well.
Can everyone, I hope you'll be able to continue that work in the future, because it's certainly a fascinating way to go. I'm not seeing any hands raised at the moment, but some great questions in the chat room, and I think it's getting close enough to the hour that Dr. Ned Calonge, if you could put up some of the last slides, but Dr. Calonge, Jane Disney, Juyong Shin, thank you so much for sharing your knowledge and helping us to see this sort of range from citizen engagement to government regulation and action to biomedical research all around this prevalent toxin. I guess I'd put in a last question, which is, when we get to the point where we're trying to, Jane, I know from your work that with arsenic, a lot of the work you've done with your citizen scientists who've been testing their wells has been about responses like filtration, just to immediately cut off the source. Is that possible with PFAS? Is that the answer that we'll see at the well water level, at the municipal water level? Is that really the way we're going to have to go?
Yeah, I think it is. Reverse osmosis systems can take a lot of PFAS chemicals out. And so I think filtration is what people should look at first, or switching to bottled water if they can't afford to put in a system right away. But I would advise them to get off the PFAS drinking water. And depending on level, as recommended in Dr. Calonge's report, talk to their primary care physician about the exposure that they've had. And there's maybe things they need to be screened for that they haven't considered. But yeah, filtration is going to be important. But I think that based on what I'm learning with arsenic, it's just not easy for people to find these solutions and then to maintain systems over time. What we find with the arsenic is that improperly maintained systems sometimes accumulate more arsenic, and it's worse what people are drinking than if they hadn't filtered the water. So I think people are going to need help with maintenance. And, I'll just go all out and say that I think everyone in the state of Maine should have the same access to clean, healthy, safe water, and that it's something that ought to come from the state and municipal level, that if everybody on public water is guaranteed safe drinking water, everybody on private water should be guaranteed safe water. And it's going to, take some legislative action in addition to filtration.
A call to arms here at the end. Knowledge will only increase our power when making such demands. So I appreciate all the knowledge that the three of you have brought to this conversation. Drs. Calonge, Disney, and Shim. Many thanks to you and the audience. Now, if this has left you feeling a bit thirsty, you might want to join our next Science Cafe, whose subject is the science of beer. It's going to be in person only, and you can understand why, at Fogtown Brewing in Ellsworth, Maine. That'll be on Thursday, September 28th. It's, as I said, it's in person only. Space is limited, so you want to sign up as soon if you can. And if you want to go, at mdibl.org/events. I also want to give you my email. I'm not sure if Ned's been able to pull up my slides at this point, the ending slides. Oh, yes, great, wonderful. My email is fbever@mdibl.org. And please send me any questions or comments you might have for the future, and I will try to route those to the appropriate places. And I think that about covers it. I just really want to thank everyone, audience and scientists, for making this such an informative event, and to look forward to keeping the conversation going. Thanks once again for joining today.